Welcome to Hillary Topper On Air, the podcast you can't afford to miss.
Our world has changed. For example, do you know anyone today without a mobile device? Between new apps being developed every day to new technologies, including 3D printing, wearable tech, augmented reality, virtual reality, these technologies have changed the way we've done business. I'm Hillary Topper, and this is Hillary Topper On Air. Today, my guest is Dr. Michael Nizick, who is the Director of Entrepreneurship and Technology Innovation Center, ETIC, and Adjunct Assistant Professor of Computer Science at the New York Institute of Technology on Long Island. Welcome, Michael, to the show.
Oh, thank you for having me. It's a pleasure to be here.
So can you tell us a little bit about this Entrepreneurship and Technology Innovation Center that you call ETIC?
Oh, I sure can. I know it's a mouthful, but we usually just call it the ETIC. It was created and established here back in 2015, but it was kind of opened as a New York State certified incubator, a business incubator, in 2016, which is around the time that I came on as a director. So, the ETIC serves two purposes for NYIT. It does act as a business incubator for local, internal, student and faculty entrepreneurial activities. If anybody has a company or wants to do a startup company based on a technology they created. But we also work with any outside companies or entrepreneurs that may need equipment that we have, so if they need consulting services or equipment that we have, such as 3D printers or big data analytics lab or software development centers, we act as an innovation center for them as well.
So cool. And I also heard that you have Microsoft HoloLens there. I'm so excited. I want to try that one day. Can you tell me a little bit about what you actually use it and what it does?
Sure, absolutely. Yeah, it's really one of the coolest technologies around today. The ETIC is set up in different research areas. Augmented reality or mixed reality is one of those areas. We also have additive manufacturing and 3D printing, and we have resin printing, and we have PCB electronic board printing. So we have a lot of things for the companies and the students specifically to learn on. But on the augmented reality side, just to put it into a certain domain, virtual reality is when you have the glasses on and you can't see anything, and it's almost dangerous to move around. And augmented reality is more like a 2D Pokemon Go world where you're overlaying digital content on top of real content through your phone camera or something like that. But mixed reality through something like the Microsoft HoloLens, in this case, it's a headset that you wear on your head, but it's a full wearable computer that is a full Windows PC. But it actually lets you create, through a software called Unity and Visual Studio and C#, which is the programming language, it actually lets you create holograms. And you create holograms that are then placed in your purview along with the rest of your real world. So you get to actually interact with those holograms just like they're really there. So when I do demos for people not from an educational point of view, just from an educational point of view, but from a testing point of view to see how something would work, you almost have to kind of check twice. You're second guessing yourself as far as what's reality, what's not, because you're seeing something that nobody else sees. It could be a person, it could be an object, but it's in the real world that you're working, and it stays still. It uses the Kinect technology from Microsoft, so it lets you walk around the object and it lets you interact with it, and it stays put. So you could take a picture of a computer that's not really there in the room, place it on a desk, and it'll stay there. When you turn around, you won't see it on the other side of the room. But when you turn around, it'll be in the exact spot that you put it in. So
wow.
we use it, yeah, it's incredible. It's incredible. So we use it to take some of our diagrams that we do in computer-aided design, and we're now researching how to very quickly and efficiently take those 3D CAD diagrams that would normally go to a 3D printer and take maybe 5 to 18 hours to print before you see the prototype. We're using it to try to figure out how to very quickly take that 3D diagram and turn it into a hologram so that we can fix the problems with the hologram, go back and fix the problems with the design without going through the full print process, to even streamline the prototyping process even more.
Wow, that is awesome. So tell me some of the other innovative features and equipment that you have there in addition to that.
Sure, I'd love to, yeah. So we have, our student body is made up of mechanical engineers, electrical and computer engineers, and computer scientists and cybersecurity professionals. We also have an energy management program, and an environmental program as well. So between these programs, we have a lot of students that are just brilliant. They're very kind of motivated about their education and want to get into the workforce. So this is a place they come, and through our different areas, and our activities. I'll talk about the activities in a little bit. But through our different research areas, they come in, they can work with Raspberry Pis and Arduinos in dedicated research areas, which are small computers that are the size of your hand, but they're about $50 and they operate just like a full PC. It's an incredible tool for the students to build new technologies with. They have a full cybersecurity sandbox with every operating system known, with routers and firewalls and switches that they can get full hands-on activity with a networking environment plus cybersecurity techniques and procedures. They have electrical engineering area for PCB printer boards. So a PCB printer is like a 3D printer for circuit boards. Normally when you design a circuit board, either by hand or in a piece of software, you have to send it out to get printed and come back, and then you have to manually put it together. We have printers here that actually print the circuit board as you're creating it. So it's, again, from a rapid prototyping point of view, we can very quickly design these complex designs all in one room, really. And we have a energy research area where students can work with wind turbines and work with solar panels and charge reusable batteries that they can then get activity from a hands-on activity point of view, can actually see how things are how energy is generated from the sun, from the wind, and then turn it into actually we have a whole area of our lab that we can run directly off of a battery operated grid. Then we have, of course, our additive manufacturing section, which is kind of one of our pride and joys, is the 5 3D printers for PLA printing for plastic, and then we also have 2 resin printers. The difference is that the plastic printers are incredibly useful, but the print quality is of a grainier, low quality. We want to start producing medical prototypes for the biomedical world, and the resin printing allows us to print at a much higher detail rate because it's really the flaws that would be in a PLA printing are not in resin. So we have both worlds. We also have a subtractive manufacturing area where we work with milling devices that take a block of wood or a block of plastic or chemical wood and cut it down. Basically, it's from a block into that. So we have subtractive manufacturing too. Then we have a 4-node big data Hadoop cluster for MapReduce code that students that want to work with large data sets. This lab allows you to code and work with the small data set exactly like it would be with a large data set, but then we can move it in places like Brookhaven National Labs where they have the supercomputers that can actually run terabytes and terabytes of data based on their code. So they have a place here to work and make it work right on a sample database and then move to one of the larger partner systems that we have to run that data. And then finally, we have the iPhone development area. We have 6 Apple PCs with Xcode to develop iPhone apps. And then we have our software development area, which are 3 high-end, high-performance PCs that run all the code that all the software development environments that you would need to run to create Android Studio, Android apps, software apps, Windows-based software, Java-based software, all in one area. And plus, most importantly, HoloLens, augmented reality, and mixed reality software applications for holograms.
Wow.
Yeah.
That's
yeah, I know.
Amazing.
And I did all the talking, so I'll say wow too.
So let me ask you something. Can you give our listeners a little insight into some of the student innovations?
Yeah, I'd love to. That's the most fun here, and it's the most rewarding. I love taking on bigger projects, and I love taking on some things that come from industry. But honestly, watching these students light up, we all in the STEM world, we do a lot of volunteer work for the STEM initiatives, and we always call it the light. You see that light in that one student's eye that really gets you going, and that's what happens here. You give we work through our seminars here that we give at the ETIC for student entrepreneurship. We teach them about starting a business, teach about fundraising, we teach them about protecting their intellectual property, but mostly we teach them about identifying how their idea is actually going to convert into some societal impact, right? So we walk them through the process to say, are you doing this? For what reason are you doing this? For what reason are you going to build it? And who's going to benefit from it? And watching them go through that process and think about this, their design gets better. They wind up thinking about, through these programs that we provide you for the students, their thinking gets clearer and more concise, but their prototype gets better. It keeps getting more and more features because they start thinking about how it's really going to apply. So what we do, it's very hard, to motivate people in general, of course, right? And especially in a school, if it's not credit-based or they're not getting paid or whatever it is. So we host competitions. I find engineering students are amazingly competitive, just like more so than like a team of athletes would be. So by having competitions and saying, maybe you can do this, but we're not sure. They eat it up. They're like, I can do this. They go and they recruit their team members together, and it's funny there. They recruit. You wind up, I call it the rock star, scenario. Or the rock band scenario. They wind up with a team of 4 people that they register with, and by the end of the competition, it's different teams because they're finding that one team needed a programmer and had 2, so they changed teams, and one team needed a mechanical engineer and they changed. So by the end of these competitions, we have one going on now that'll May 9th will be having 4 teams compete with new technologies they're creating to solve the United Nations 2017 Sustainable Development Goals. We wrap it around those goals because when we were trying to build these competitions out originally and trying to come up with problems ourselves, they're very subjective. Things I care about might not be what students care about and so forth. But when you have 196 countries that get together and say, these are our problems and they got to be solved by this generation by 2030, which is what the SDGs are, it gets really, really, almost emotional. These kids start looking at this saying, wow, I had no idea that's what was happening to our water. I had no idea that's what happening to our atmosphere. I had no idea that's what's happening to children around the globe, right? If you ever look at these SDGs, they're equal opportunity to education, equal opportunity to healthcare, how do we solve these problems? And our competitions, they're engineering competitions to build new devices and new technologies, but they're based around the UN SDGs. And it really is a motivating factor. They get attached, they get emotional, they care about what they're doing. And through this lab, above and beyond the laboratory facilities I told you about before, we have all kinds of supplies. We run a program called eCycle here, where we bring high school students in to bring them into the STEM world, and they take apart a lot of electronics that we would throw away normally, and that plastic would go into dumps and whatever. So they break apart these devices, they throw the plastic away and recycle it, but all the parts that they see, the motors, the lasers, the gears, the drive forces, the wires, they're all used by our senior design teams and our competition teams. So we're taking recycled parts and competing in a competition to build new technologies for the United Nations Sustainable Development Goals. So it's a really cool world for the students.
That is really awesome. Well, before we move on, I just have to say that I'm so appreciative of our sponsors and must take a second out to thank them. Please support our sponsors and tell them that you heard about them on Hillary Topper On Air. Special thanks to the Russo Law Group, MetPro, once again, Nut Butter, and Fortunoff Fine Jewelry. Now back to you, Mike. What types of student entrepreneurship programs do you have at ETIC?
So we talked a little bit about the student body before and the different areas of interest they have. Mechanical engineers are not necessarily interested in computer science and so forth. So, and we're an engineering school. So to run an entrepreneurship program out of a school like this, we have to try to build programs that attract all the different types of students and different types of majors so that they can actually focus on the same goal, which is entrepreneurship, right? So we run a couple of different programs. The one thing that we found, and these programs emerged out of 2.5 years of work for me now that have things that haven't worked, I just don't do anymore, or things that did work, I figure out why they worked and how do we make them bigger, and things that were in between, we consider each one. So, but these are the ones that we found, extremely successful. So we have a series of hackathons, which are entrepreneurial in nature. So in a single day, students are asked to come up with solutions to problems and document them and defend them. Students are asked to, from a cybersecurity point of view, we ask them to break encryption algorithms throughout the day, and a prizes award at the end, and their methods are turned into an entrepreneurial type effort. We run the student entrepreneurship program, specifically called the SEP, that we call it, and these are students that actually have they either have a business already, and we just help them with that business, move it along, or they really do totally want to start a business, and we help them with that process. We also have the intellectual property program that we started this last semester as more of a trial run or a pilot program, but this semester we're running it pretty formally. And from that program, we teach them about patents and trademarks and copyrights and the value of protecting your property. But because of that program, we actually have 3 patents getting written right now. 1 is a faculty student initiative and 2 are student initiatives. So the lab is now actually becoming a source of intellectual property origination, which is just, I'm so proud of. And it's all from the work these students are doing.
And that was my next question, so how do innovative centers like ETIC contribute to the region? And you already answered part of it. Is there anything else that you would add?
I think it has to be said that the biggest thing a college of any kind, not just NYIT, but any college of any kind, can contribute to the region are its students. And I say that because there's a lot of talk in other directions that we want to kind of be honest about, right? So preparing our students to do better and stronger and more efficient work at local and regional companies is the best thing we can do. We're ready for it. It's our job. It's supposed to happen. The students are paying for it. It's exactly what should happen out of the school. And the region can benefit mostly by having one single place to go to in these schools, regardless of where that is. If it's career services, wonderful. If it's a lab like this, wonderful. But they should have a single place or a few different places at a minimum from these schools to sit there and say, hey, I've got an opening coming up. I like to plan my next 3 months of hiring. Let's start doing the interviews now. That's the best way that schools can help industry and industry can help schools. That being said, we run a couple of different programs, and one is called TIP, Technology Internship Prep Program, where any student participating in any ETIC activity of any level qualifies for the TIP program, but they're required to get their resume in order. They're required to do a presentation of the work that they're doing in the ETIC, regardless of what it is. They're required to interact with industry when they're looking for people to say, look, I'm going, almost like a job interview. And industry representatives are welcome at any time, at any point in their workday to come in here and say, when are your students going to be here? Because I want to interview a computer science major. I want to interview a mechanical engineer. I want to, an electrical engineer. So that interaction between industry and the schools is the most part. And the only other thing I'll add to that is that being an innovation center, the one thing as an engineering school that we're really good at is thinking and prototyping and researching. It's what we do. It's what our faculty members do. It's what our students are learning to do. It's what we do. So if you have a problem that you're not sure of and you just can't dedicate the time to the problem, this is a good place to come. These centers are really good places to come to say, can I just talk to you for a few minutes and just see what you think? And we'll say, oh, here's what we think, and here it is. Here's where all the different pieces lie, and here's what we could do about it. Now, again, does something happen after that? That's up to the company as far as what they want to do. But it's a really great place to just come and hang your hat for an hour for a cup of coffee and try to figure out what's going on that you can't figure out. Maybe we can.
Wow, that's an awesome service. So tell us exactly where you're located and how someone can learn more, or do you accept volunteers also?
So the answer to the first question is that we have 2 campuses. One is in Old Westbury in New York. We have 2 again. One is Old Westbury, and one is in Manhattan in Columbus Circle. The ETIC physically is in Harry Shearer Hall at the Old Westbury campus. We work with faculty and students on any kind of projects, any kind of competitions from all of our campuses. It's just that physically located, the labs we talked about and the services we talked about are available at the Old Westbury campus in room 107 in Harry Shearer Hall. So that's the first piece. Any outside business, whether it's an established business or even a startup or an entrepreneur that wants to We have a very affordable part-time usage rates of like $150 a month. Full-time usage if you want to store stuff here or access any of our abilities for $300 a month. So companies can actually, use the facilities if they have if the work they're doing fits in with what the school's goals are, and if they're going to help the students and things like that. So there's ways that companies can benefit from it as well. And that's essentially from a location point of view, that's where we are.
It's awesome. So tell our listeners how they can get in touch with you and learn a little bit more about ETIC.
Sure. The best way to go is go to nyit.edu /ETIC, ETIC, and you'll land on our page. You can read about all the recent news that we have going on, different student activities, different competitions. There's a link there for become an ETIC partner. It's like a form fill out. You just fill it out. My information's on there, my telephone number, my email, so you can always contact me directly. So those are the best ways to get going. And also just stop in. I mean, if you just stop in and say, I heard about this thing, we're here from 9 to 7, Monday to Friday. And if you want to just stop in and take a tour of the lab, either myself or one of the grad assistants will be here to kind of tell you what each section does and how it works.
You're doing amazing work. Thank you so much for sharing and being on the show. I really appreciate it.
Oh, my pleasure.
And I want to thank our sponsors again, the Russo Law Group, MetPro, once again, Nut Butter, and Fortune Fine Jewelry. And last but not least, I want to thank you, our listeners, for tuning in. If you want more information on this show or any other show, visit our website at hillarytopperonair.com or find us on Spotify, iTunes, Google Play, SoundCloud, you name it, we're out there. Have a great week, and we'll see you next time.